You ever look up at a massive airplane cruising at 35,000 feet and think, yeah, that thing is basically defying gravity like it's no big deal? Well, the real hero isn't the wings, and it's definitely not the snacks. It's the engine. And not just any engine, we're talking Rolls-Royce jet engines. These aren't just machines. They're precision monsters built with insane attention to detail, costing millions of dollars each, and designed to run nonstop for decades while pushing hundreds of tons of metal through the sky. Today we're breaking down exactly how Rolls-Royce engines are made, step by step, from raw materials to one of the most advanced pieces of engineering on the planet. And trust me, this process is way crazier than most people realize. Rolls-Royce doesn't just wake up and start bolting parts together. Everything begins with design, and we're talking years of it. Engineers use next-level computer modeling, AI simulations, and digital twins, basically. A virtual copy of the engine that gets tested thousands of times before anything is physically built. Every blade angle, airflow path, and temperature point is calculated down to microscopic tolerances. One tiny mistake here could mean millions lost or worse, so nothing is left to chance. The goal is simple but brutal. More power, less fuel, lower noise, and extreme reliability. That balance is insanely hard to pull off. Once the design is locked, material selection comes into play. And this is where Rolls-Royce really flexes. These engines don't use regular metal. They use advanced titanium alloys, nickel-based superalloys, and proprietary materials designed to survive temperatures hotter than lava while spinning at thousands of revolutions per minute. Some parts operate in conditions so extreme that if they were exposed to open air without cooling, they'd literally melt. And here's the wild part: Rolls-Royce actually develops many of these materials in-house because nothing on the market is good enough. Now, let's talk about the fan blades, because this is where things start getting iconic. Those massive blades at the front of a Rolls-Royce engine, they're not metal. They're made from carbon titanium composites, super light, insanely strong, and engineered to survive bird strikes, hailstorms, and ridiculous pressure. Each blade is precision molded, layered, cured, and then inspected again and again. And yeah, each blade is unique. No shortcuts, no mass-produced nonsense. Behind the fan is the compressor section, and this is where airflow gets serious. Air gets pulled in and compressed through multiple stages, each one squeezing it tighter than the last. These compressor blades are machined with extreme accuracy using multi-axis CNC machines that cost more than most houses. We're talking tolerances thinner than a human hair. One blade being off by even a fraction could wreck efficiency or cause vibration. So every single piece is checked, scanned, and rechecked. Next comes the combustion chamber, aka the heart of the engine. This is where fuel meets compressed air and explodes in a controlled way thousands of times per minute. The challenge here isn't just power, it's heat. Combustion temperatures can exceed 2,000 degrees Fahrenheit, which is hotter than the melting point of the metal itself. So how does it not melt? Science magic, basically. Rolls-Royce uses advanced cooling techniques, ceramic coatings, and complex internal air channels that keep the metal alive while fire is raging inches away. Then, we hit the turbine section, which might be the most mind-blowing part of the whole engine. Turbine blades extract energy from the hot exhaust gases, and they spin so fast the tips are almost breaking the sound barrier. These blades are often single crystal components, meaning they're grown as one continuous crystal structure to eliminate weak points. That process alone takes days and requires insane precision. After that, they're coated with thermal barriers and polished to perfection. Assembly is where everything comes together. And this isn't some loud, greasy factory floor. It's clean, quiet, and controlled. Engineers wear gloves, sensors monitor everything, and each step follows a strict sequence. Engines are assembled in modules, which makes maintenance easier down the road. Every bolt has a specific torque value. Every connection is logged. Every move is documented. Rolls-Royce doesn't just build engines, they build traceability. But the real flex comes after assembly, testing. These engines don't just get a quick spin and a thumbs up. They're tortured. They're strapped down and run at full power. They're exposed to extreme temperatures, vibration, pressure changes, and emergency scenarios. Engineers simulate bird strikes, ice ingestion, and sudden shutdowns. If something fails, the engine goes back. No excuses. The standard is brutal, because lives depend on it. 1. thing people don't realize is that Rolls-Royce doesn't just sell engines. They sell uptime. Through their power-by-the-hour model, airlines pay for engine usage, not ownership. That means Rolls-Royce stays involved for the entire life of the engine. Sensors inside the engine send real-time data during flights, feeding AI systems that predict wear before it becomes a problem. Maintenance isn't reactive, it's predictive. That's a whole different level of engineering. Another crazy detail, some Rolls-Royce engines are so precisely balanced that engineers literally shave microscopic amounts of material to get everything perfect. We're talking grams, sometimes less. That balance reduces vibration, increases efficiency, and extends lifespan. It's obsessive, and that's exactly why these engines are trusted worldwide. And let's talk scale for a second. One Rolls-Royce Trent engine has over 20,000 individual parts, thousands of suppliers, years of development, and once it's in service, it can stay flying for decades with proper maintenance. That's not just engineering. That's long-term thinking on steroids. What really separates Rolls-Royce from everyone else's mindset. They don't chase cheap. They don't chase fast. They chase perfect. Every process is designed around reliability, safety, and performance. When you're flying across the ocean at night, you don't want good enough. You want something built by people who are borderline obsessed with getting it right. So next time you hear that low, powerful hum during takeoff, just remember inside that engine is a masterpiece of modern engineering. Thousands of hours of design, some of the most advanced materials on Earth, extreme testing, constant monitoring, and a legacy that goes back over a century. Rolls-Royce engines aren't just made. They're engineered, refined, and perfected. If you enjoyed this deep dive and want more, behind the scenes looks at insane engineering, aviation tech, and how the world's most powerful machines are built, you already know what to do. Drop a like, hit subscribe, and stay locked in. Because trust me, this stuff only gets crazier from here.